Hello everyone. So today I'll be teaching you, I'll be demonstrating an example how to generate a grid for ROMS application using a MATLAB script called Easygrid. This Easygrid was originally prepared by ROMS team manager Rob Hetland, and after some modifications for the recent version of data available, this is successfully able to create the grade as per my requirement for the application in ROMS. So first, let me share you the screen. Yeah, so as you can all see, this is the code for Easygrid generation. We use the Easygrid script to create our NetCDF grid for ROMS. The first basic requirements of using Easygrid are: in your MATLAB directory path, you should have the following items. As you can see from here, you should have the stretch file. You should have these of the following folders added to your MATLAB path: stretch file, NetCDF 4.2, NetCDF toolbox, MaxCDF, Easygrid version 2. And that's it. And that's all you would require for Easygrid plot generation. Note that this should be added to your MATLAB path, otherwise this Easygrid script will not work, as there are a lot of dependencies on which this Easygrid is based. There have been few modifications added based on my personal requirements in addition to the original script, so as to create a variety of scripts. So just let me run you through a general example. So as you can see, here is the Easygrid script. It's in .m format. So the first thing you need to do is you need to decide which region you want to make a mesh of. So for that, you need to have two things, two set of files. Now, if I open my Easygrid folder, I see the following two set of files. I have one, this Easygrid MATLAB script. Then I have the bathymetry for that script present in the .mat format, and then I have the coastline data of that region in the .mat format. Note that Easygrid is a useful grid generation tool only when you have the bathymetry and coastline in a .mat format. Okay, now moving on from here, once you have everything in your path, first you need to ensure that you have all the paths of the scripts added here. So you can directly use the command add path.scripts. It has directly been mentioned in the script, or you can even pass the command in the command line. It won't create an issue. Now for creating a grid, you need to just follow a bunch of easy and basic steps. So you can tweak with all these parameters, but the main thing is that in order to create a grid, you need to first switch on the create grid attribute. Then if you want to see how the grid looks, then you can switch on the plot grid. And first thing I would say is, without smoothing the bathymetry, you need to generate the grid, and then in successive iterations you can smooth the bathymetry depending on your requirement. So this bathymetry smoothing is an iterative process, so it needs to be done in a number of times, and I'll teach you how to do that. So basically I have just switched off this smooth grid parameter. Then edit mask is 0 because currently we are not focusing on editing the mask of the grid. Then we have the screen output just to display all our outputs in the command window. And then we have two options, save grid and save init. Since we don't need the initialization file, we have switched it off to 0. And since we need to save the grid, we have switched it on to 1. Now coming to the grid settings, I am creating this grid for the fjord of the Nova Scotia region, Ship Harbor. So for that, I'll be switching on to Google Maps. Note, now this is the region of my interest for which I want to create the grid, this domain. this entire domain, and for that I need to mention the latitude of the bottom left corner and the longitude of the bottom left corner. Now if I can see from the map, a rough estimate will show that if I point something from here, I get the latitude and longitude as 44.76 to 62.86. Now rough estimate, you can put it to anywhere as per your requirement, but you need to just mention the left coordinate, and that's it, and that's all you would require. So after mentioning the left coordinate, let me just change it to 76, and this one is 62.86. 62.86. Rest all you can keep it as per your requirement. Now, the width of the domain in x-axis and the length of the domain in y-axis is to be mentioned in meters. So I have taken a 9.1 kilometer stretch and 2,500 kilometer stretch. Now, this rotate is not usually required if you are creating a straight grid. I usually turn it off, but for this case, since my region is rotated, so I'll keep it at an angle of minus 45 degrees approximately, or 43, whatever is the requirement. So I'll set it at minus 45 degree clockwise. So the resolution is basically the dimension of each cell. Since we are creating a rectangular grid, we will be having an area of 100 for each cell width and height. Now this will decide the number of grid points in the x-axis and the number of grid points in the y-axis. Now this one, n is equal to 12, is the number of vertical levels you require to create a forcing. Number of vertical levels required to create a forcing. Since this is a 3D grid, this is essential, as when adding forcing files, these forces will be added to different layers of our domain. Now coming to the bathymetry, we don't need analytical depth, so just keep it as none, because analytical depth will consider the entire depth as constant and will have a rather flat bottom, which is not the case. And since we are using a bathymetry file, you just need to mention the bathymetry file in the .NET format in here with the correct extension and the correct name. As you can see, a bathymetry file has got the bathymetry and its format is .mat format. So you need to take precaution and enter the .NET format. Now coming to the coastline. For coastline, I have the coastline format, which is also in the form of fjord underscore coast.mat. This is easy. You can get it from any source as you want. You can get it from any source as you want and just import the file in here. Now the final thing which you need to change is the grid file name. Now the grid file name is what you want the file name of your grid to be. So in that case, I will just need to, since it's an fjord, I'll just keep it as a fjord. Now reference date, you need to set your reference date in here so that the .ocean file uses the same reference date as your other forcing file. This is a very important parameter, and make sure your all the reference dates are same in each and every file, whether it's your forcing file in the wind, forcing file in the tides, or your grid file as such. Now the ocean time parameter is not a very big deal. What you can do is you can just set it to any value you want. It will just put an offset from that time. So for example, if you want 2000 data from 2011, so you have to see like for 5th April 2011, so you have to calculate the total number of seconds from your starting date to 5th April 2011 at 12 a.m. if you want, and just add the ocean time in here. NH4 and NO3, these are just the chemical parameters which you may add, you may not, no need to add. I don't really tweak those parameters, as those are not my values of interest. Salinity is also not my value of interest. Temperature potential for the initialization file, you can keep it as constant. I keep it as 9, or you can keep it as 10, whatever you want. And the initial velocity is 0, as all the initial velocities will be taken from my tidal forcing, so I really don't need to change these values. And thus, this is the end of whatever you need to do in the Easygrid script. As there is no other tweak that needs to be made, what I'll do is now. Now all you need to do is just run the command and wait for it to be executed. Now you see, since I have mentioned a different region, a different plot came. So that's why I suggest you to use the exact coordinates where you want your region to be. Now as I open a different script, as you can see in here, I have a separate copy of it where I have kept all my files. This is not an issue, so I'll use the exact coordinates in here. I'll use the exact coordinates in here for the region I require. So just moving on to here, that was just for demonstration purposes for how you can do it. Now this you need as adjustment. Now I have kept all other parameters as same. Now in order to do so, what I will be doing is I will switch on the save grid as a file, and I will just run the Easygrid script. Now the plotting is done and you can see I get the exact dimensions, domain of the grid. Now this is what we would actually require in this case, and hence her job is pretty much done. What you need is ensure that all your files are in the same path, and every time you do things, you need to mention that the path is constant. As you can see, my path is tpxo, a C drive users, ABC documents, MATLAB, and tpxo, and I'm exactly in here, and I can see all my grid file and my initialization file present in here. So that's our Easygrid tutorial. Thank you. There are lots of other grid generation options, but Easygrid is the best one and the easiest one to use. So on that note, I will stop recording. I hope you understood the tutorial pretty well. Thank you.